Welcome back, Radiant Scholars. Paper 2 is in a week, so let's jump right into it. So we can simply go between the class intervals and then plot the frequency. Then all we have to do is just connect the points together, because we're drawing a frequency polygon. Oh, I don't have a ruler, but of course you'd want to use a ruler in the exam. Just like that. And then for the mean, you can use the midpoint of the intervals times by the frequency for each of them, add them up, and then divide by the total frequency, which is 30. So that'd be 12 times 1 plus 16 times 4 plus ... And I'll just put that in my calculator. Our total is 620, and our total frequency is 30. So we would do 620 over 30, which is 20.6 recurring, which is about 20.7. For this, all we have to do is just fill in the tree diagram. So winning chess is 0.6, which would mean that losing is 0.4 because probabilities sum up to 1. And then winning backgammon is 0.7, regardless of if she wins or loses chess. So losing it would be 0.3. And then winning both games would be up here, and that would just be 0.6 times 0.7. Because we take both of the probabilities and multiply them together. So this is our standard form number. Simple, just write it out. You can jump 1, 2, 3, and that's right. And putting that into my calculator gives me 3,690,000, which is equivalent to this in standard form. So our original price multiplied by 0.85, because that would be 15% off, would equal to 612. So then our original price would be 612 divided by 0.85, which is 720. So density is mass over volume. We know the mass, so we just need to get the volume. And that'll just be the pi r squared times h, which is 108 pi centimeters cubed. So our density would be mass over the volume, which is about 7.81 grams per centimeters cubed. And you need to make sure that the units are correct. Fortunately it was, but probably should check next time. Here we need to look at what numbers will round to 5.4, and that would just be simply 5.35 and 5.45. Well, 5.45 wouldn't actually round to it, but since it's a less than symbol, it would be like something like 5.49, which would round to it. So we can just say that something like 2p is equal to 110, and the total is 6p, which would be 330. Sophie would have 3p, which is half of that, and that is 165. So we know that the total money they have is 330, so the new amount in that new ratio 2 to 6 to 7 would be 15q equals 330, and q would equal to 22. So now Sophie has 2q money, which is 44. So let's write out all their monies first, and then it will be a lot simpler. So originally Sophie has 165, Thomas has one of these, which is 55, and then Umar has 110. But now Sophie has only 44. And then Thomas has 6 Qs, which is 132. Then Umar has 7, which is 154. So, I mean, you could just easily do 154 minus 110, which would be 44 given to Umar by Sophie. I mean, that could have been done a little bit simpler, I guess, because we only needed to really work out Umar before and after. But yeah, just for completeness, I suppose, what I like to do is just keep dividing by 2. It's like the easiest way to do it. And then immediately we already have the answer, which is 2 times 3 times 3 times 5. You don't have to do it like this, but if it does ask for it, then you do, of course. So we can work out this angle here, which would be the internal angle of the regular polygon. And that would just be 360 minus those two, which would be 165. And then we could just find the external angle, which would be 15. And so since we know that 360 over n would equal to the external angle, we can just figure out n by rearranging it for 360 over 15, which would be 24 sides. Okay, so this is a throwback to my very first lesson, I'm pretty sure. The product rule for counting, we would do 30 times 29 and then divide that by 2. Since we know there are 2 different ways to arrange the same 2 people, which is why we divide by 2. So we can just make an equation which would be 2600 times by 1.048 and then timesing that by r twice, which would eventually equal to 2846. And so we could just get r squared as 2846 divided by 2600 times by 1.048, which would equal something, which I'm just going to keep on my calculator, and then square root that to get r as about 1.022. Actually, I shouldn't have used a capital R because this doesn't represent the answer, but the r that we actually want is as a percentage, so this would be 2.2%, because the r that I wrote is the multiplier, but the answer wants the interest percentage. So I'm kind of lazy, so I'm just gonna speak. So we can compare the medians by looking at this. The year 11s took longer on average because the median is higher at 19, and the year 11s had a bigger spread of times because the interquartile range is bigger. Okay, so the way to do this is to look at the differences between the terms, which would be 4, 8, 12, and then 16. And since the differences aren't the same yet, we can do the second difference, which would be 4 on all of them. And then we know that the coefficient of the quadratic in our sequence would be half of the second difference, which is 2. So let me write out the terms for this. So for 1 it would be 2, then 4, and then 18, 32, and then 50. So the differences from this to this is 7, 5, 11, 13, and 15. So that looks like an arithmetic sequence because they're all going up by 2. That would be 2n plus 5 for this sequence here. And so since this sequence up here is actually less than this one, we're actually going to be subtracting 2n plus 5. So our final sequence is 2n squared minus 2n minus 5. So the area of a sector is the angle over 360 times by pi r squared. And we know in the question it's equal to 47.9. So we can just do a little bit of rearranging, and then at once we'll get 95.0 degrees. That's what that looks like rearranged, by the way, for x, if you wanted to see it. So our center of enlargement is at the origin here, and we have a negative scale factor, so it's going to go all the way over here. So just multiply by -2 on each point, then connect up, again with a ruler in the real exam, hopefully. I really like to just count the squares, so since this one is like 2 up and right, I would go 2 up and right, and then again, because it's -2. And then I can see that this distance is 3, So in the new one it would be 6. Same up here. And then since this one is like right once and then down twice, in the new one it would be right twice and then up 4 times. So like this. So that's how you can just do it really quickly. Oh, frustums, haven't seen these in a while. So we can just get the curved surface area of the big cone, which would be pi times r times L, which is 10. And that's 40 pi. We want to know the radius of this small cone here. And since the height of the small cone is 6, we know that the scale factor would be 10 over 6, which is 5 over 3. And so 4 divided by that would be 2.4 for this radius. So that means the curved surface area of this small cone is pi times 2.4 times 6, which is 14.4 pi. So the surface area of this base here, or on the curved part anyways, is 40 pi minus 14.4 pi, which is 25.6 pi centimeters squared. I have a calculator for a reason. And then we can just get the areas of the top and bottom and then just add it onto that. So pi r squared for both. And add these 3 together for 47.36 pi centimeters squared. And that's still in pi, so let me just multiply that by pi to get 148, just about. Oh well, that rounds to 149 actually, because it's 148.78. Yep, 5 marks. Okay, so we can just like multiply the denominators out to collect them all together. So multiply this x plus 3 on the side, then multiply the middle one by x minus 3, then multiply the very last one by both of them on the left, which is x minus 3 and x plus 3. So these are all under, well actually no, they're all over x minus 3 and x plus 3. Yeah, this is pretty big, but we can just collect them all together in the next line. So that would be 2x squared plus 6x minus 3x squared. Let's see, minus 9x minus x is minus 10x, and then that's minus, so it's plus 10x. Then plus 3x, and with the minus it's minus 3, plus x squared, just the difference of 2 squares. All of that over the difference of 2 squares. So I can see that the x squareds cancel out because there's 2 minus 3 plus 1, and then we've got 6x plus 10x, 16x, and then minus 3 minus 9, which is minus 12. That was pretty quick. So really wish I had a ruler right now, which we can estimate by getting the gradient of the graph at that point. Okay, so this is like the worst digital ruler I have ever used. Yeah, that is not even on the point, but hopefully that's right. So we've got change in y over change in x, which is minus 25 over 7 minus, let's say, 1.2, and I've got minus 4.3 meters per second squared. Obviously my one's like not really accurate. It's probably going to be a range of like 4 to 5 or something, or I mean minus 4 to minus 5. So obviously in the real exam you'd want to get as close to the gradient of the line at that point as possible, but don't be worried if it's like not too accurate, because there'd be quite a big range. Okay, so we want to see how far it travels in the first 6 seconds. We're just estimating it with 3 strips. That'd be like this, this, and this. And these are just 3 trapeziums. Okay, this is just a mess. Okay, I've copied it into the question so we can actually see it. So that'll just be half a plus b times h. Now h for all of these is 2. I don't think you can really see it with the lines drawn on, but that middle one is actually 12.5, not 12. And the last one is 5.5. So that just gives 87.5 meters. So let's write out our proportions. It's inversely proportional, then it looks like that. So y equals, let's say, k over x squared, is our constant. And then 28 is equal to k over x squared, and then k is just 28 times 1.5 squared, which is 63. Find the negative value of x when y is equal to 7. Let's just rearrange for x squared, I guess. Which would be 63 over y. So x squared equals 63 over 7, which is 9. Well, rooting 9 would usually give just 3 because square root is always positive, but it's asking us to find the negative value specifically, which would be minus 3. So I could just use the area of a triangle formula to start off with. So half AB sine C is equal to 58. So our length DC would be about 9.88. So now we can use the cosine rule to find AC. So I'm just going to put all that into my calculator. That would give us 17.0581, just about. So we can use the sine rule in our triangle up there, because we can just find the angle at BAC, which would be 180 minus 112 minus 51, which is 17 degrees. And then what we're looking for? We're looking for BC. So BC over sine of it, which is sine 17, is equal to the length of over the sine of that one, which is 112. So BC is equal to 17.0 something sine 17 over sine 112, which is finally about 5.4 no, it's not centimeters, it's about 5.4 meters. It's a nice 5 marker. So composite functions, got f of g of x, which is just f of 3x plus 5, and that would equal to cube root of 3x plus 5. So h is equal to f of g of x, which is that. Now we want to find the inverse, so let me just use my strategy of replacing the function with y, cube both sides, rearrange for x. Then simply we can just replace everything, and we've got our answer. A bounds question. So for bounds questions, we want to find the lowest possible value and then the highest possible value. So for the lowest, we want to have the numerator as small as possible and the denominator as biggest as possible, and then vice versa for the largest. So for our smallest, we want to have the smallest v possible minus the largest u possible over the largest a possible. That will minimize RT. Let's just write out enough so we can compare the two. Well, I said enough, but that's just all the digits on my calculator all. And then for our largest, put the biggest v minus the smallest u over the smallest a. And that's 2.7944. Yeah, we definitely don't need all of these digits, but I started, so I might as well keep doing it. And then we can just clearly see that rounding both of them to one decimal place gives 2.8. It would be 2.8 to 1 dp. this is the best approximation that they both round to. If we say had 2 decimal places, the top one would round to 2.77 and the bottom one would round to 2.79, which are different. But if we have 1 decimal place, they'll both round to the same thing, which is 2.8. And that's your explanation. So we could just solve this by substituting the linear one into the quadratic one. Multiply everything by 4, just to get rid of this denominator at the bottom. Then I can probably just use my calculator at this point. So, got 2 solutions. X equals 2, and then I'll write it all the way over here. X equals minus 6 over 33, which is minus 2 over 11. So now we can just substitute it back into y. So y was equal to 6 minus 5x over 2. Just do it for both of them. So we've got our 2 pairs of solutions as we would expect, where x is 2 and y is minus 2, or x is minus 2 over 11 and y is 38 over 11. Okay, and for our final question, we have a circle question. Okay, at least it's not a circle theorems question, thankfully. We know that the equation for a circle is x squared plus y squared equals r squared. So r squared is 45. So rooting that, we'll just get root 45, which is root 9 times root 5, and that's just 3 root 5. And then we can probably just like draw out our circle. Not a perfect circle, but gets the job done. 3 minus 6 is like down here. So we want to find the tangent, which is like that. So simply we can just find the gradient of the line connecting the origin to this point 3 minus 6. So that would just be change in y over change in x as usual, which is minus 2. Then the gradient of our tangent is the negative reciprocal. And then finally, y equals mx plus c. That would mean minus 6 minus 3 over 2, minus 15 over 2. So our final equation of our tangent is y equals half x minus 15 over 2. And that's all of it. So keep pushing forward as you're already halfway through the season, and good luck on your next exams.